Hello friends, so here is another question. So it is given that two stones are projected or thrown from the top of a 288-meter high tower, each with a velocity of 48 meters per second. One stone is thrown vertically upwards and the other one is thrown vertically downwards. Calculate the time each stone takes to reach the ground and the velocity with which each strikes the ground. Okay, so let us say we have a tower. Okay, first let us draw a tower. Okay, this is the tower which is 288 meters high. There is some kind of a place here from where two stones are thrown. One stone is thrown vertically upwards with a velocity of 48 meter per second. So here one stone is thrown vertically upwards with a velocity of 48 meters per second and another stone is thrown vertically downwards with a velocity of 48 meters per second. So we have to determine the time taken by each stone to reach the ground and the velocity with which each one strikes the ground. Okay, so now first let us consider the stone which is moving upwards. So for that let us just bring this figure a bit downwards. Okay, so now here this stone, this will take first, it will travel upwards, it will go to a certain height, from there it will come to rest. Okay, it will come to rest and then it will start its downward journey. This is the upward journey, then it will start its downward journey like this, and finally it will reach the ground. Now if you remember, in the previous question we discussed the motion of a free falling object under the influence of gravity when it is thrown upwards and it is thrown downwards. There we discussed that if we have an object which is thrown upwards vertically at from the ground level at a certain point, if it is thrown with a particular initial velocity, it comes down with the same velocity. Okay, it comes down with the same velocity. If it is thrown upwards with a velocity of x meter per second, it comes down with the same velocity x meters per second, and the time taken for the upward journey is the same as the time taken for the downward journey. Tu is equal to Td. So here for the upward stone, the stone's upward journey from here to this point, identical point here, the stone from here to here, from this platform at the top of the tower, from here to here, identical points, the velocity with which it is thrown, it is 48 meter per second. It means at this point its velocity, downward velocity, is also 48 meters per second downwards at this point. Okay, the time for the upward journey is the same as the time of the downward journey from here to here, from the same point, this level. Okay, this level. So we have to determine the time. We already know the velocity with which it is coming downwards at this point, which is 48 meter per second. Now we have to determine the time. So here, for determining the time, we'll be using the equation of motion. V is equal to u plus at. During the upward journey, final velocity is 0 meters per second at this point, rest. So it is 0. Initial velocity is 48 meter per second, with which it is thrown upwards. Acceleration due to gravity is acting downwards. Motion of the object is upwards, so it will be negative 48 minus gt. It will be uv is equal to u minus gt, that kind of a thing. So here it will be 9.8 into tu, upward journey. So that implies tu is equal to 48 by 9.8, which is coming around 4.89 seconds. Okay, so the time taken for the upward moving ball thrown with a velocity of 48 meter per second to finally come to rest is 4.89 seconds. Now it will take the same time to come downwards up to the same point. So the total time taken for the ball to go upwards and to come down up to the same level, this level, it is 2 into 4.89 seconds. This is very important. Okay, then the second part, which is from that level, after coming down, it is coming down with a velocity of same with which it was thrown upwards, that is 48 meter per second. Then we have the height of the tower, which has to cover 288 meters. Okay, this. So it will take certain time to cover this 288 meters until it reaches the ground here. Here, for this journey, the initial velocity is this 48 meter per second. The distance which it has to cover, s, is equal to 288 meters. And here the motion of the object is downwards. Acceleration due to gravity is also acting downwards, so it will be positive. It will be taken as positive. And now we have to determine the time which it takes to cover this 288 meters distance, the height of the tower. Let's call it only t. The time is t. Okay, so here we'll be using the equation s is equal to ut plus half at square. So here that implies 288, which is the distance. Ut is 48t plus half into plus 9.8 into t square. Okay, this. That implies 288 is equal to 48t plus 4.9 t square. Okay, that implies, bringing everything on one side, 4.9 t square plus 48t minus 288 is equal to 0. If we divide 4.9, okay, if we divide 4.9 throughout, then it will be t square plus, here it will be 9.8 t minus 58.8 equals to 0. Okay, that much equals to 0. So let me just check again so that there are no mistakes. .48 by 4.9, just one. Yes, and then we have 18. Yes, it's all 58.79 it is coming, so 58.8 we'll write it. Okay, yes. That implies this is in the form of a quadratic equation. So in order to determine t, we'll be using t is equal to minus b, it is ax square plus bx plus c equals to 0, that form. Okay, so it will be minus b plus minus b square minus 4ac, okay, by 2a, 2 into 1. So it is coming around, okay, it is coming around in the form minus 9.8 plus minus 18.2 by 2. So we'll be using this minus 9.8 plus 18.2 by 2, because negative time is nothing, there is no such thing as that. So it'll be 9.8 plus 18.2 by 2, so it is 8.4 by 2, which is equal to 4.2 seconds. So again let us clear something out. This is 4.2 seconds. So now if we consider the journey of the upward moving stone, here the stone which was thrown upwards, first it took 4.89 seconds to go up to the highest point it can go, finally coming to rest. Then it took 4.89 seconds again to come back to the same level from where it was thrown. Then it took 4.2 seconds, okay, 4.2 seconds to come back to the ground. This, the total time is equal to 4.89 plus 4.89 plus 4.2 seconds, which is equal to 189, which is 13.98 seconds, which is the total time taken by stone which is thrown upwards to come back to the ground. Okay, now with what velocity it is coming to the ground? For that, what we'll do is that here it was thrown with a velocity of 48 meter per second upwards. It came back with the same velocity, 48 meter per second. So from this 288 meter height tower, if we consider this much, it is 48 meter per second. Here this is the initial velocity for this much portion, and here we have to determine the final velocity with which it is coming. So for that we'll be using v is equal to u plus at. Okay, v is equal to u plus at. Here t will be equal to 4.2 seconds. Okay, a will be equal to plus g, which is equal to 9.8 meter per second square, because downward motion, acceleration due to gravity is also downward, so it will be plus. So final velocity will be equal to initial velocity 48 meters per second plus acceleration due to gravity 9.8 into t, which is equal to 4.2. So it is 48 plus 9.8 into 4.2, and that is equal to, it is coming around 89.96 meters per second. This much. So the velocity with which the stone, which was thrown upwards with the velocity of 48 meter per second, it is coming downwards to the ground, okay, to the ground with velocity of 89.16 meters per second. This is for the first stone, okay. This is the case of the first stone which was thrown upwards. So again, I am making it clear. The stone was first thrown upwards with a velocity of 48 meter per second square from the tower. It travelled upwards, came to rest at this point. Then it came down with the same velocity from the same point where it was thrown. At the same level, it came down with a velocity of 48 meter per second square. The time taken for the upward journey is 4.89 seconds. The time taken for the downward journey is the same, 4.89 seconds. From that point where it came, from where it was thrown initially, from that point, it had to cover the whole height of the tower, 288 meters. For that, we took the initial velocity 48 meter per second. Then we used ut plus half at square, that formula, to determine the time it took to reach from the top of the tower from where it was thrown to the ground, which was 4.2 seconds. And we used v is equal to u plus at formula to determine the final velocity with which it struck the ground, which is 89.16 meter per second. Now, if we consider the other stone, okay, if we consider the other stone which was thrown downwards with a velocity of 48 meter per second, then it will be the same thing, okay. The time it took to reach the ground, it is the same as this, okay, this equation, s is equal to ut plus half at square. In this case, initial velocity will be equal to u, which is equal to 48 meter per second. Then the distance it will cover, it will be equal to 288 meter, the height of the tower, which we have done already, So it will take the same time, t is equal to 4.2 seconds here also. It is the same case of the downward journey of the stone from the height of the tower, okay, the platform from where it was thrown to the ground. The same thing. Of the first case, the second part of the journey, it is the same as the downward journey of the stone, okay, the second one. So same, t is equal to 4.2 seconds, and the final velocity with which it strikes the ground, that will be equal to same here, which is 89.16 meters per second. Okay, this 89.1, because every parameter is the same. Okay, here it was thrown upwards, it came to rest, it arrived at the same point with the same velocity. Here it was thrown downwards with the same velocity which with it was thrown upwards. So same thing. Okay, the journey of the stone after it arrived from this point to this point, in this case, is the same as the journey of the stone which was thrown downwards from this point to this point. Everything is the same. The time it took to reach the ground is 4.2 seconds using this formula and this result, and the velocity with which it strikes the ground, which is v is equal to 89.16 meter per second, it is the same as this, which we calculated here. This one and this one. Okay, so it is a very good conceptual question. The important thing here is the previous question which we solved, where we analyzed the motion of a free falling object or a motion under gravity, where the four important conclusions came into play. The velocity with which the object is thrown upwards, it comes down up to the same point with the same velocity. The time taken for upward journey is the same as the time taken for downward journey. The velocity at different time instants, identical points, identical time instants during the upward and downward journey, they are the same, and it takes straight line identical path during its journey upwards and its journey downwards. It takes the same identical straight line path. Okay, so this is the